Hi, this is Keenan Maxfield. I'm an instructor with Solar Energy International, and I just got a question from a student, so I'm going to address it. It's regarding the point of interconnection rules found in Article 705.12b23a and Article 705.12b23b. And I'd like to address that today, and I'm going to start off with a little bit of background or a little bit of review to bring us up to speed first, and then I'm going to address the question. So I'd like to start off by bringing to our remembrance that in Article 690.9b1, 690.9b1, it states that our overcurrent protection device must be greater than or equal to 125% of our maximum output current from our inverter. So basically our minimum breaker size is 125% times our maximum current, hitherto known as Imax. Minimum breaker size. So now, going back to 705.12b23a and 705.12b23b, hitherto I will refer to those as option A and option B. Let's write that down. 705.12b23a. We see that in option A, it says that under this option, our maximum, let me just read it straight out of the code. It says the sum of 125% of the power source's output circuit current and the rating of the overcurrent protection device of the bus bar shall not exceed the ampacity of the bus bar. So basically, to paraphrase that, it's saying our Imax times 125%, or rather 125% of our Imax from our inverter, plus our main breaker rating. If that is less than or equal to 100% of the bus bar rating, then we are allowed to put our breakers anywhere in the breaker panel. It doesn't really matter. Now notice that this 125% of Imax here is the same as our minimum breaker size. So assuming we use the minimum breaker size, which we normally do, then we could reword this to say inverter breaker plus main breaker is less than or equal to 100% of the bus bar. Hope that makes sense. That's pretty plain and clear. Basically, if there's no way that more than 100% of the bus bar current could possibly get into that panel, then we really don't have to worry about it. We can put those breakers anywhere. However, option B, let me erase this paraphrase so that I don't run out of space. In option B, it says that if we put our two breakers, our main breaker and our inverter breaker, at the opposite ends of the bus bar, then the sum of 125% of the power source's output circuit and the rating of the overcurrent protection device protecting the bus bar shall not exceed 120% of the bus bar. So again, going back to our initial paraphrase, it's saying that 125% of our Imax from our inverter plus our main breaker, and that in this scenario needs to be equal to or less than 120% of the bus bar. Now again, you notice this number here is the same number as our minimum breaker size. So, assuming we're using the minimum breaker size, again, this is saying our inverter breaker plus our main breaker can be less than or equal to 120%. of the bus bar rating. So the question is, what is the logic behind this? Why are we allowed to actually exceed the bus bar rating as long as our breakers are on either side of the bus bar? So I'm going to draw a little illustration of why this is still safe to do. So if we have this bus bar and we have, let's say we have a 200 amp breaker here going to our grid. And then over here we've got a 40 amp breaker, which really, remember, that's our Imax times 125, so that's really a maximum of 32 amps. But anyways, that's a 40 amp breaker because that's the minimum breaker size for a 32 amp circuit. And that is going to our solar panels, or to our inverter. So let's just say that we had a random number of breakers. And let's say that we had 20 amps, 20 amps, 10 amps, 20 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 amps, and 20 amps. Now this is an entirely impossible scenario. Well, I should say highly unlikely that you would actually have even numbers of amperages flowing simultaneously on this many breakers, but just for hypothetical reasons. Let's say we had exactly this many amps flowing on each one of these breakers. So if I did my math right, this adds up to 230 amps. And so you'd start off with, see, this power from the solar panel, if it's actually putting out 32 amps, then it would be flowing here at 32 amps, and it would drop out 20 amps there, and then the other 12 amps would come here. So right here, it's 32 amps. But then over here, it's dropped down to 12 amps. And then over here, you've got this 200 amps flowing. It would actually be less than 200 amps, but it would be 198 amps right here. And 20 amps would drop out there. 20 amps would drop out there. 10 amps would drop out there. 20 amps would drop out there. 20 amps would drop out there. 20 amps drops out there. 20 more amps drops out there. 20 more amps drop out there. And so on, until this is supplying, here it's only supplying 8 amps to this load that our solar is not providing. So as you can see, this starts at 198, and there it's 178, and here it's 158, then here it's only 148, here it's 128, here it's 108, here it's 88, here it's 68, here it's 48, here it's 28, and here it's just that extra 8 amps to combine with that 12 amps to make the 20 amps here. So as you can see, at no single place on this bus bar is the rating being exceeded at all. So that is the logic to why we can exceed the total capacity of our bus bar as long as our sources are coming from opposite ends. I hope that makes sense. If you have any questions at all, feel free to send them to me. Have a great day, and thank you very much.